do one more time. Let's do one more time. Let's do one more time.
Hi everyone, this is Chycho, and I'd like to welcome you to Series 3B of the Language of Mathematics. Now, this series is a continuation of what we did last year in Series 3A. And since it's a continuation of that, I'd like to do a little recap of what we did last year, which was basically we started off, it was supposed to be a series about the equal sign in units, and we started off fine. I started talking about the equal sign and the different symbols that have branched off the equal sign and what the equal sign means. And basically it's just, equivalence, right? Trying to compare one thing to another thing, seeing if this side of the scale equals this side of the scale, right? And again, there's other symbols that branch off from there, right? Some of them, they're
inequality symbols saying that one side of the equation is larger than the other side of the equation, or one side is smaller than the other side of the equation. There's congruency when you come to geometry, trigonometry. You can have the element of when you go into number theory, set theory, basically, where you can say these numbers belong to this set. And we talked about some of this stuff in series 1 as well with the real number set, right? When you say 1, 2, whole numbers going up, or whole numbers 0, 1, 2, 3. All the way up to infinity, they would belong to a whole number set, right? They're the element of the whole number set.
So I sort of touched on the equal sign at the beginning when I made a couple of videos about comparing two things, and I took it to the extremes to try to make a point. I went to the smallest
thing that we've been able to measure in the real world, and the largest thing, some would say the largest thing that we've been able to measure in the real world, and that's black holes and elementary particles. And I put a couple of videos together just at the beginning, try to emphasize the point that when you go down, when you break it down, when you're talking about two things, you can always compare two things. Initially, a lot of teachers say when they're initially trying to introduce units to people, and I've done this myself too, is they always say, you can't add apples and oranges, right? If you go apple plus an apple is, 2 apples plus 2 apples is 4 apples, right? And your units there would be apples. And, they say, try to make sure that students don't add the wrong units together. They say, you can't add apples and oranges together, right? And I've done this myself, been guilty of it myself. However, that's not really true. You can add apples and oranges together as long as you break them down to a specific unit, right? So 2 apples plus 2 apples is 4 apples. 2 apples plus 2 oranges is 4 pieces of fruit. So what you're doing there is finding a common unit between two things that you're comparing. And that's where the importance of units comes in. That's where the importance of how it relates to the equal sign comes in. So there was a little bit of talk about that at the beginning of Series 3A. So we sort of messed around with that a little bit and, brought it down to the point that if you're talking about something, it's really important to know what property of that thing it is that you're talking about, which is units. Now from there I was going to expand on units and talk more about the equal sign units. But what I did is sort of take a tangent. I went off on a tangent, and that occurred when we started talking about the equal sign and how to move around the equal sign, right? How you can take numbers and move them over, or solve for equations, or solve for variables. And we dealt with addition and subtraction, how you move around when you have addition and subtraction. Talked about how you move around with the multiplication, division, exponents, and radicals, which is basically, if you're trying to get rid of something on one side of the equation, you do the opposite to it. And if you do something on one side of the equation, you got to do it to the other side of the equation. That's what the equal sign is, right? It's a scale, it's a balance. If you're trying to keep things balanced, if you put something here, you got to put something here. If you remove something here, you got to remove something here, right? And that's how you move around the equal sign. We also talked about, one tool I like to use, and I teach this to a lot of my students, is cross multiplication. I know most people have encountered hate fractions. So what I like to do is get rid of fractions initially, anyway, with simple equations. Get rid of fractions right away. And if you have one fraction equal to another fraction, all you do is take the denominator here, and you cross multiply up, right, across the equal sign, and that gets rid of your fractions. And we talked about that a little bit, and sort of solve equations. And we solved some simple equations. From there, we kicked it into quadratic functions, quadratic equations, which are basically anything in the form of ax squared plus bx plus c. And these are just polynomials. Quadratic equations are polynomials of degree 2. And to solve quadratic equations, what we talked about was the different factoring techniques that we have to solve quadratic equations, which are basically 4 manual, 1 using a formula. And 4 manual are the greatest common factor, GCF, simple trinomial factoring, the difference of squares, and complex trinomial factoring. And the 5th one that we use a formula for when we can't easily factor things out, which is a quadratic formula. Now out of those 5, we've already talked about GCF, and GCF you use anywhere for any type of polynomial equation or non-polynomial equations. It's basically the greatest common factor. Anything similar between them, you can take them out and put them in the front, right? So we talked about GCF, we talked about the simple trinomial factoring, and what we still have to talk about is the difference of squares, complex trinomial factoring, and the quadratic formula. We're also going to talk about another form of factoring that we use to factor larger degree polynomials, larger than quadratic function, larger than degree 2, which is synthetic division. And that is used for anything larger than degree 2. And we're going to talk about that, right? So what we ended up doing was, talk about quadratic equations specifically and some other, some higher degree functions as well, where, we talked about what it means when we're factoring a quadratic equation or when we're factoring a polynomial equation, which is basically factors of anything. Factors of a polynomial equation or quadratic equation are the x-intercepts. And there's multiple terms that mean the same thing when we're talking about factors, right? When we factor a quadratic equation, what we're getting, the solutions, are basically the x-intercepts, where the function crosses the x-axis. And you also refer to that as, the zeros, the solutions, the roots, the factors, and, the x-intercepts. So whenever you're factoring for something, when you get x equals something, multiple things, or, x only equals, one number, what you're really getting is solving for, what the solution gives you is where the function crosses the x-axis. And we talked a lot about this. Basically, we're exploiting the property where if you have multiple things multiplied together to give you 0, the way you solve for any type of equation like that is take each, what you do is exploit the property of 0 where the only way you can have multiple things multiplied together to give you 0 is if at least one of them is equal to 0. And since you don't know which one is equal to 0, you solve for all of them equaling 0, right? And sometimes all of them give you solutions, sometimes none of them give you solutions. Sometimes you get, some give you solutions, some don't give you solutions, right? And we talked a lot about this stuff. One of the things we did when we were solving equations, we talked about, some of the things that you cannot do when you're solving an equation, which is eliminating solutions, dividing by 0. Dividing by 0 basically gives you asymptotes in the polynomial equations, and checking solutions, right? So checking solutions is quite important. Initially when I start teaching these techniques to my students, I get them to check their solutions because I don't want people to take for granted that the answer they get at the end really solves the equation. It's a valid solution. Sometimes you might have done everything correctly, but once you substitute it back into the polynomial equation, the solution doesn't make sense, so you have to eliminate the solution, right? So checking solutions, checking answers is important. And, we did a fair bit of different types of equations. Some polynomial, some not polynomial. We did a fair bit of polynomial, but some were not polynomial equations. And we'll touch a little bit further on those non-polynomials. So from, factoring and graphing quadratic equations, we got our hands really dirty with this stuff, right? And from there, at the end of Series 3A, what we ended up doing, what I did was take a step back and went, in depth into the terminology of what a polynomial equation is. And I put up 3 videos towards the end talking about polynomial equations, talking about, what they can give you, what the x-intercepts means. And we sort of did a summary and defined a lot of terms and explained what it is that we're talking about when we say polynomial equations, right? And that's where we left off Series 3A. In this series, in Series 3B, we're going to wrap up the factoring techniques, talk about the remaining four techniques, right, which are, what's left is difference of squares, complex trinomial factoring, quadratic formula, and synthetic division. So we're going to start solving more quadratic functions and more polynomial functions. And we're going to talk a lot more about polynomial functions in general and start graphing polynomial functions and, maybe see where we can apply them and some of the polynomial functions or quadratic functions that we have in the real world, right? So that's where we are. That's where we left off Series 3A. This is where we're going with Series 3B. I'm also going to do, put in as additional stuff in there as well, wherever I think, something is needed. If we need to start discussing something else specifically related to polynomial equations, we will start talking about it, okay? So this was sort of just a quick little recap, just give you a, rapid explanation of what we did last year. And I forget how many videos there are. It's 2 to 3 hours worth of material on there, 4 hours maybe, worth of material on there that we're sort of recapping. If you're not familiar with that series, you should take a look at it, because what I'm going to do is probably just jump, continue that right away. So I'm not going to do too much recap in the videos coming up. I will do a little bit just to, just to remind everyone what it is, what's going on, and what we're talking about, so people aren't lost, because there has been a few months gap, a year basically, since I did the last video, and that's about it. That's what we're going to do for Series 3B. And one thing that has changed for this year is. For the previous 3 years, what I did was, I had the summers off, so what I would do is do as many videos as I could for the summer before my work kicked in the fall. And in the fall, I would take a break. One reason I did that is because I had work coming up in the fall. And the other reason was the weather was nice, so I could go outside and do my videos, on walls outside, right? That's changed. My schedule has changed because math, these videos, this is the project I'm going to be focused on for the foreseeable future. So I'm going to continue Series 3B until I'm satisfied that we can, end it and then start the next series. And the next series, I'm not sure if it's going to start right away after the series is done or not. I might take a little break and do a little bit of back-end work to hopefully get the websites up. I'm still going to do that on the side. That's one of the things I'm going to do while I make these videos. But so this thing is not going to end, in a couple of months or whatnot. I'm going to continue this and probably shoot into the winter. It's going to be, I'm going to go into the cold, so you're going to see smoke coming out of my mouth, and I'm going to be dressing a lot warmer. And one thing I'm going to do, as soon as the weather starts getting a little colder, is I do miss my beard, so I'm going back bearded style. So hopefully for this series, you're going to see a beard slowly growing on me. Okay.
Anyway, that's it. I hope that's, that reminds people, if you followed it from Series 3B, I hope that reminds you of what we did. And I hope you're looking forward to this year, because I am. I'm seriously looking forward to it, and I got a few lessons already organized to shoot, and we'll take it from there. We'll see where we go. And welcome back. Glad to be back again, and I guess I'll see you guys in the next videos.